Basic relays. So this will be a review over the basics of how relays operate. These basic concepts will help you understand how all relays work. Now the first thing to understand is that we use relays as a switch. We use that switch to turn off and on and off whatever we're trying to control. We'll start with a so-called ice cube relay, a slang term for these since they look like one. Let's look up close at the features of this relay. So first of all, notice inside the relay the marking AC24V. This is the coil of the relay, and it works as an electromagnet. When we apply voltage to the coil, to the relay on these two pins right here, it energizes this coil and acts as a magnet, pulling on the copper plate called common, and it moves its position from one set of copper contacts to the other set of contacts. Let's have a look inside this thing. Now, one of the nice things about these kind of ice cube relays is looking at a couple of things, you can determine that these two pins are the pins for the magnetic coil right here. Other ones with round arrangements aren't so easy, but this is kind of nice. If you look up in close and personal here, you can see that these two pins are vertical in reference to these other ones that are horizontal. Now the two ones that are vertical are going to always be the pin to energize this coil right here. Okay, these other pins, this is a double pole single throw type of relay, and these other pins will be common, will be normally closed and normally open. Okay, so let's have a look at these contacts here. If you can see, this is the common plate, and if I move it with just my finger here, you can see how it goes back and forward between these two sets of contacts. Now, what I'm pointing at right here, this plate that goes between those two sets of contacts, that's called your common. And many times as electricians, we think of as common as a neutral. Well, you can see common doesn't necessarily mean neutral. It just means this plate here is common to either to these contacts, if I move them here, or if I move them to the other set of contacts. So that's one of the first things that we have to understand, that word common, many times again we've thought of that as neutral. But it could be anything that we're trying to switch. Okay, so let's take another look here. So as you can see, as we're looking at this relay, this common is resting on this set of contacts. They're actually touching. You can see that right here. And they're not touching the set of contacts. So the set of contacts are touching, we always refer to that as normally closed contacts because this is touching. Now, one thing you have to remember is that when you're looking at a relay on a schematic or a drawing, it's always going to show it in its de-energized state, which basically means that this electromagnet is not engaged. So another way to think about this is calling it the resting state as well. And you can see, again, another thing what I like about ice cube relays is they kind of show you the inner workings here. You see this little spring on top. When that relay is not pulling that coil in, that common plate in, it's going to rest in the normally closed. Okay, so again, that's the resting position. Okay, so what does all that mean? Well, that simply means that when you have something uncommon, you can switch it between normally closed, normally open, depending upon your needs. And you switch it by engaging this coil here, this electromagnet. And we're going to have a look at how that works here in a moment. Okay, as you notice, I have some wires coming to this base for this relay. Okay, here's a relay over here, plugs into that base. And again, what's so nice about these type of relays is I know, again, that these two pins are different from those on their position, just like this. So I know that's going to be my coil voltage. My control for my coil is going to come in through here. So I'm going to go ahead and plug this in. Now, of course, I have the top off just so we can on this so you can see the operation a little bit easier. If you also want to see what else we got going here, is that's 24-volt coil. So what I have coming over here is I have a little desktop power supply going to that little transformer there, and I'm taking the 24 volts going over here. Now I also have a multimeter that we're going to be using here. You'll hear that briefly when you hear, and we're going to ring out the contacts. But first of all, again, this is in its de-energized state. So you can see that the contacts aren't touching right here, and that's normally closed. And we're going to go ahead and test our meter. You can hear that. So I just did a continuity check. So if we look over here, on this side is going to be our common contacts. We can ring that out too. You can see that. This is common to that plate there. Okay, I can touch that. And you can see that. Now, you have one on this side, but no continuity there, so I'd have to go to the common over here. Because again, this is kind of nice. This is a double pole relay where I can have different inputs coming on each one of these commons. For right now, we'll just play with this one. So common to normally closed. And again, you see that right there. Normally closed on the pin configuration is right there. This is normally open. So without this being energized, this is not on, I'm going to have continuity between my common and my normally closed. Now if I had a load connected to this, let's say a light or something, that light would be lighting up if I had power on my common here and the other wire going, let's call it a switch leg, to my light, just for familiar terms. Now let's go ahead and energize this. So before we do, let's once again, we have continuity there. Now this is also kind of neat because you can watch the contacts move when I energize this. So off, energize on. Again, that becomes an electromagnet. And what's nice about this one too is it also shows, this one's got a little red LED on there that lights up. So here we go. Let's check to see, do we have continuity at normally closed? Not anymore. We do have it on normally open, however. Okay? So that's pretty cool about this. So we're on normally open because this is energized. We kill the power, we're not on normally open, we're on normally closed now. Okay? So again, some what I really like about this, kind of related, as a first introduction to them, is they're pretty simple to see, the contacts moving and everything else. And again, let's do a little up close and personal. Just have a look at those contacts. See how they moved? And again, that's because that AC24V is that coil where we put power on the base with me switching over here with my other hand. And that changes position. And that is the basis of all relays, all basic relays. And we're going to look at a ladder diagram that goes with this so we understand that basic operation. Okay, now we're going to look at this relay as far as it would look in a ladder diagram. And I did put some other explanations in here, hopefully to make it more clear for you. But let's look at this. So remember the coil voltage for that relay, okay, was 24 volts. So we're using 24 volts to switch it on. So this is indicative of my switch. Once I close that, it energizes the coil. Now this is a universal figure for a coil. And CR you're going to see many times, just basically coil for the relay, CR, okay? Over here, L2 common, right? So there's 24 volts. Now, so what does that all do? Well, down here, we're going to take an additional leap forward here. Let's think that we have a red and a green light that are going to go, that could have been wired up to our contacts. And here's where, relays come in really handy. So if you notice right here, I said 120 volts on L1, L2, common or neutral. We'll just figure that. That's easy to understand, okay? For us electricians, neutral. So if you look over here, CR, why I put CR is, when you see it in a diagram, it's associated with that relay, okay? You'll always see it called maybe CR1 or whatever. In this case, we're only using 2. So this is CR as well. This is the CR normally closed relay, and that's the symbol for normally closed. Okay, it looks like a contact that's got a line through it, which would, or shorted out, which would look closed. So with that switch open, and with this resting here with 120 volts, that red light's going to come on. Okay, now once we flip that switch over, our coil energizes, and remember these coil contacts will change state. So the red will not be illuminated anymore, but then the normally open will close and the green light comes on. So I think this is, a good basic way to understand how all relays work. We're using usually a much smaller voltage or a lot less amperage, maybe even might be the same voltage, but we can switch a much larger load or a different load. We can switch anything we want with these things. So again, basic information about how a very basic relay works. Hope this helps.